Greetings, amazing scholars. Today we're going to work some problems that have to do with algebraic reasoning, graphing, and connections to geometry. I've created a PowerPoint to work out our problems. Okay, let's get started. So, problem number one, it wants us to find a graph that correlates the function of the amount of gas in a gas tank when a driver refills the tank on a drive across the country. All right, so this is a graph that I chose. Right here, it could show how much gas was in the car. It shows right here, him going, needing gas. It's getting low or empty, whatever. Him filling up, and then his drive across the country. So I put over here the gallons of gas, and down at the bottom, the distance driven. Now, our second graph, it needs us to correlate the function of the height of an elevator stopping at each floor on the way up. So, it looks like stairs, but we'll use right here is going to be our floor. So, here's the first floor, the second floor, third floor, and so on. And this is the height of the elevator at each floor it stops on. All right, now problem C. It wants us to correlate the function of a bouncy ball. So if we have a bouncy ball and we drop it off of a table, it wants us to show a graph that represents that. So here's our graph. And if you think about it, it really honestly looks like what it would look if you dropped a bouncy ball. So here's the height of the bounce. So when you drop a bouncy ball, the first bounce is usually the highest. And the number of bounces, the height decreases. All right, and our last graph that it wants us to correlate the function for is the length of a shadow of a flagpole throughout a sunny day. So we went with this graph. Now, this will be the length of our shadow. So right here is the longest part of our shadow of the flagpole. So this will be like the brightest part of the day, and then as the sun slowly sets, the shadow decreases. Let's move on to problem number two. Now with problem number two, it wants us to do these functions. So it gives us f of x is equal to 3x, and g of x is equal to fx plus 8. And it tells us that the variable x, we got 0, 1, 2, and 3. So you can do this algebraically where you'll just plug in the value of x to each equation and solve it. So like for this one, f of x is equal to 3 times 0, which gives you 0, and so on. Or you can use Excel. So that's what I did. I just plugged in my functions over here and solved for the values and inserted this graph, all with Excel, and it took like maybe a minute. So the green line is our function of f of x is equal to 3x. Our blue line is g of f of x is equal to fx plus 8. It's very simple. I mean, I'm usually a number girl, but when you can just plug the stuff in and it does it all for you, and just bam, there's your graph. It's pretty awesome. All right, moving on to problem number 3. Now with problem number 3, it gives us 2 points, and it wants us to find the slope of the line segment. Now in order to solve this, you're going to need to plot your points. So right here we have 3, 1, and then 5, 5. And you connect it with the line. So this one's pretty simple. The numbers are fairly small that you can just use this little formula of rise over run. So we just count up 1, 2, 3, 4, and over 1, 2, which gives us 4 over 2. When you reduce it, it's 2. So the slope of this one is 2. And if you can tell, the slope goes upward and to the right. Now I've also worked it out, how you figure it out using the slope formula. So you just plug in your points, y2 minus y1 over x2 minus x1, which I've done here, which will give you 4 over 2 with the slope of 2. Let's move on to our next one. Now this one gives us our points, so we want to graph 5, 8. There's our point 5, 8, and 5, negative 8. Now, let's connect it with our line. If you look at this line, you can tell that there's no slope. This line segment is vertical, so it just goes up and down. So the slope would be undefined. All right, now we got a bunch of negatives. So, all right, here's our points plotted. So we got -1, -4 is here. And they've got -4, -13 here, and you connect it with the line. Now for this one, since the numbers are so big and different, and just this one, I figured it'd be easier to do the slope formula. So I have it worked out right here. So we have, which our y2 would be -13 minus a -4, which is our y1, over x2, which is -4, minus x1, which is -1. So -13 plus 4 gives you -9. -4 plus 1 gives you -3, which gives us our slope is 3. All right, so number 4. Number 4, it's going to give us 3 functions and wants us to graph. So here's our functions that it gives us. It gives us y is equal to x squared, y is equal to x squared plus 7, and y is equal to x squared minus 7. For this one, Excel is your best friend, I promise you. You just type in your functions, you give an X column, you put in whatever numbers you want. I just did -10 all the way to 10. And then you just type in your stuff and it solves it all for you and gives you all these numbers. Then you insert it into a graph, which I have done for you guys here. Now the green line is our function of y is equal to x squared, this one. Our blue one right here is y is equal to x squared plus 7, and then the yellow is y is equal to x squared minus 7. Now, if you look at our parabolas, do you see any differences or similarities? To me, they all look very similar, like the same kind of curve, just shifted upwards. So we start with our yellow, then the green goes up higher and blue goes up higher. So they're very similar, just a different shift upwards. Okay, let's go on to number 5. This one, it gives you an equation and a point, and it wants you to find the perpendicular line to our equation. Now, for our first equation, y is equal to -3/4 x plus 5. It is already in slope-intercept form, which is y is equal to mx plus b. So the formula I have up at the top is slope as a point slope form, sorry. All right, so we know from y is equal to -3/4 x plus 5 that -3/4 is m, which is our slope. So the perpendicular slope is the negative reciprocal of our regular slope. So the negative reciprocal of -3/4 is 4/3. Now we use our point slope form right here. Y minus y1 is equal to mx minus x1. So you just plug in the information you have. So we have y1, which is a -1. We have our slope, which is 4/3, and we have our x1, which is 6. And then you just work out our problem. Our perpendicular equation would be y is equal to 4/3 x minus 9. And I have this beautiful little graph here. So the green one is our line equation that they gave us. And the blue one is our perpendicular line. And you can tell that they are perpendicular. Do one more. This one is a little different for the simple fact that the equation is not in slope-intercept form. So we are going to have to get it into slope-intercept form so we can figure out what our slope is. All right, so let's work this one out. So we have the 2y, well, we need to get that away from everybody else. So we subtract 9x and you add 5 to bring it over here to the other side. So y ends up being -9/2 x plus 5, which gives you the slope is -9/2. And for the perpendicular slope, again, it's the negative reciprocal of the regular slope, which makes it 2/9. Plug our information that we know into our point slope form down here to find the perpendicular equation, which would give us y is equal to y is equal to 2/9 x plus 3. Then you graph them. So our orange line is our perpendicular equation line. The blue one is our line equation. So the blue one is y is equal to negative 9/2 x plus 5, and the orange one is y is equal to 2/9 x plus 3. All right, let's go to our last problem. Now, on our last problem, it's wanting us to show the equation of the line that is tangent to the circle of a radius of 9 at point 0, negative 9, and whose center is at the origin. So here's our circle, and right here's the origin, which is 0, 0. We need the point 0, negative 9. So we start here in the middle, and we come down 9, which would be the bottom of the circle. Here's our point, 0, negative 9, and we need to draw us a line across it. Here's our line. Now, to figure out the equation of this line, we need to do the slope-intercept form, so which is y is equal to mx plus b. Now, we get there's no slope because the line is horizontal, but our y-intercept is negative 9. So we know that y is equal to negative 9. All right, so I drew a line at the top because the next part gives us, once it's the same thing, except instead of 0, negative 9, it's 0, 9. So here's our point, 0, 9. Again, there's no slope, it's a horizontal line. The y, our y-intercept, is at positive 9. I just showed you that, look, on this side of the circle, it's 9, 0. So over here on this side would be a negative 9, 0. Now, if you look at our two lines, it wants us to compare our lines from part A and part B. Do you notice anything with our two lines? Well, I'll let you know. Both of these lines are parallel, and if they were wanting to know the lines on this side of the circle, they would be parallel too. So our lines are parallel to each other. And that's all I have to help you with your homework. I hope this has been beneficial, and thank you guys for watching.